Hey everyone, welcome back to GraphQL Radio, the GraphQL podcast. I'm your host, Avi Iyer. Both my co-hosts are out today. It's pretty late in Berlin right now, so we didn't want to really disturb them. Nick, Johannes, well, hopefully you guys love this episode. I know Johannes met you actually, I think at GraphQL Europe, so he really wanted to be on the show today, but GraphQL is doing a lot of cool things right now, and they were just in San Francisco. Doing some fun stuff there, so cool things to come from them. But it's just me, and our guest today is the Rob Zhu from Facebook. Welcome, Rob. Thanks for coming to the show.
Thanks for having me. This is a great show, by the way. Every episode I've watched so far has been really informative, and I really appreciate the effort and dedication that goes into producing a show like this. So,
thank you. Thanks, Rob. So, a little background for the viewers. I think they've been with us, and so a little background for you. We've had actually 3 shows thus far mentioning subscriptions, and so I feel like since the React talk you gave about GraphQL subscriptions, I feel like in the community, the de facto guy to talk to is Rob Zhu. So I'm glad we got you on the show today. Before we get into subscriptions and the RFC process, which is kind of our topic for the show, I'd like to get to know you a little bit better, and I'd like our audience to get to know you a little bit better too. Do you mind giving us some introduction?
Yeah, absolutely. So I'm a software engineer on the GraphQL team, and I focus on GraphQL subscriptions. Before joining Facebook in early 2016, I was a software architect at As Software Group, which is a local Boston company that builds software for professional money managers. And then before that, I was a software engineer at Microsoft for about 8 years, where I worked in Microsoft Game Studios, the Startup Business Group, Active Directory, the .NET Framework, and a couple of other projects.
Wow, that's pretty extensive.
Real quick, you said I'm the person to talk to about subscriptions. I'd be remiss if I didn't mention the original core team members who made subscriptions possible. And those 2 people are Dan Schaefer and Lainey Kinzel. They could easily replace me in this podcast. I'm just standing in because I worked on the open source portion of it.
I see. Well, that's great. It's great to know that there's multiple people thinking about this problem too.
Absolutely.
So I think the best way to kind of give our audience the necessary information about subscriptions is to start with the history. Like, why do we care about real-time data? What's the history of this,
Yeah, it's always great to start with why. So let me try to give you a brief history of GraphQL subscriptions. And as a lot of people who listen to this podcast probably know, GraphQL had a life long before we ever open sourced it in 2015. And it began as a way for mobile apps to fetch data from the social graph. And so the mobile apps were using queries and mutations for a few years, and the interactions were generally very well regarded by product engineers. But that was only for request-response style interactions, where the client asks a question and the server provides a response. If we wanted something more real-time, we had to use these peripheral systems that were outside the graph. Either that or we had to resort to polling GraphQL, which becomes inefficient at a large enough scale. So we wanted to build a system that can unify the 2 things. That can stay within this kind of GraphQL mental model, yet it can provide a real-time API to basically tell you things in a more timely fashion and not require that you deal with your own, polling state management kind of solution.
I see.
We found that people were building these solutions around this, and whenever people are building solutions around the framework, then that it's something that's worth looking into if the same patterns come up again and again, like polling.
Definitely. So you mentioned polling, right? But there are different classes of what we consider real-time data or fresh data. Could you go into the different types of subscriptions or ways we can achieve this real-timeness?
I think the different ways that we could achieve, well, when you talk about polling, from my React Conf talk on subscriptions, I think one point to bring out from there is that polling is actually not a bad solution for it. It gets a bad rep, right? Because we look at it and we're like, oh, it's icky, it's inefficient. But some real-time use cases are optimum optimal for polling. So for example, let's say you had a weather sensor and you wanted to sample that weather sensor at 5-minute intervals. And that's the requirement. Your data should just show regular 5-minute intervals of temperature.
Exactly.
That kind of thing is really good for polling when you have a continuous plot of data and you just want to sample it at regular frequencies. So I definitely don't want to give anybody who's listening this impression that subscriptions is the one-size-fits-all solution to real-time use cases. You know, as you wisely alluded to, there are different kinds of real-time use cases, and subscriptions are really the best fit for associating GraphQL data with a domain-specific event. And I'm going to define that and get into more detail on that later on, hopefully.
Yeah, definitely. So we mentioned the use cases of a weather tracker, right? So that was a good polling use case. What are some use cases of subscriptions that maybe you've seen in your products or in the wild?
Yeah, so that's a great question. I will just go over a couple of the use cases in Facebook that you're probably very used to just by virtue of being a Facebook user that are high volume subscription use cases.
Yeah.
So these include live likes, live comments, and typing indicators. So whenever you open up a post and it says something like, hey, somebody is typing a comment on this thing, or a comment shows up magically, those comments and the state of the typing indicator, that's not polling. That's your device opening up a GraphQL subscription, and the server pushes that information to the client whenever it detects those events, like somebody started typing, somebody stopped typing. And more recently, we've launched a couple of subscription use cases that power the live video experience. So whenever you open a live streaming video and you see those reactions coming across in real time, or you see live comments appearing in real time, those are both powered by GraphQL subscriptions.
Interesting. So just as an engineer listening to you right now, naively I'm thinking, how does this even work, right? Because in my mind, there are two ways to do subscriptions. There are event-based and there are live queries, right? Mm-hmm. And what opinion is GraphQL on right now? And maybe we should just talk about how subscriptions work in GraphQL, and that'll kind of like explain like what take GraphQL is going on.
Yeah. I think that's exactly right. There's two questions in there, which is one is how do GraphQL subscriptions work, and then the other, what is the relationship with live queries? When would you want to use one or the other? They're both very interesting questions. So let's tackle the first one, which is just how do subscriptions work. And for this, I think it's useful to separate the answer into two parts. One is how does GraphQL work conceptually, and the other work when we dig into the details of the implementation. And what you'll find is that conceptually, we're describing a fairly general system, and it's quite. And then when you get down into the implementation, you now need to make some choices that will affect how the system scales and what kinds of use cases are going to be optimum for that set of components. So let's begin with the concept. Let's consider a query for a moment. It's pretty simple and it's pretty intuitive, right? The client sends a request. This request contains some GraphQL text. The server processes the request and then sends back over a response. And I'm glazing over parsing and validation. So let's just assume that that happens without any incident. Well, the subscription starts off the same way. The client sends a request to the server containing a GraphQL document. However, instead of returning a response, the server returns a stream of responses. And each response in this stream corresponds to a domain-specific event. And so as the implementation as a server that implements GraphQL subscriptions, let's say I'm the server and you're the client. If I decide to support GraphQL subscriptions, I need to do a few extra things that I didn't have to worry about back when I only supported queries and mutations. Right? When I was supporting queries and mutations, for the most part, I was a stateless server. I just got an incoming request, and I did some processing, and I sent back a response. Now I have to worry about three things that in addition to just serving queries and mutations. And those three things are, first, I need to keep an active conversation going with you so that I can push responses along the stream back to you, right? So I need some notion of a stateful bidirectional channel. Right. The second thing is I need to remember the query that you sent the query text that you sent along with the subscription request, because I need to re-execute that every time I detect the domain-specific event. And then lastly, I need to actually listen on that specific event. So we put all that together, and you tell me something like, hey, I just joined chat room 123 with ID 123, and I would like to know whenever anybody else joins the chat room.
Yeah.
We've been using that word domain-specific event a lot. And here's a perfect example of a domain-specific event. When somebody else joins the chat room. It's domain-specific because we're talking about the application of a chat room.
Yep.
It's an event because there's some sort of temporal notion of when this thing occurs, right? It doesn't just happen anytime. You can't just say, hey, I want to execute something. When you have to say, I execute this query in response to an event occurring, right? So when you submit that, if you submit a GraphQL query that says, fetch me the name of the person that just joined the chat room, when I, as the server, receive that request, I can't just execute it immediately because I don't have anything handy that says who just joined the chat room. In other words, I've only got part of the query.
Yeah.
I need the event data and the query in order to execute it and give you your response.
Yep.
And that's where I turn to a different component in the system and I say, hey, Abby just joined chat room with ID 123. Whenever anybody joins chat room with ID 123, I want to know about it. I care about that event. It's important because as soon as that happens, I'm going to join that with the query that Abby sent up, and I'm going to execute that set of data, and I'm going to get the response and send it back down.
Yep.
So that's how subscriptions works at a conceptual level. And I want to point out that all three of these requirements are stateful, which is going to be very important to consider when you try to scale the system. By and large, we have a good grasp of how to scale stateless systems.
Yeah.
But when you try to scale a stateful system, then there are a lot of other things that come into play. So we'll revisit that after we go through the implementation. But does that roughly answer your question? Does that make sense?
So it totally makes sense how things are structured. I have some follow-up questions though. So we say that we are tying queries to actual domain events, right? Mm-hmm. Now I can think of domain events in triples actually. Create, delete, update are all domain events on a particular piece of data. Can I attach those three subscriptions to one query? Or how would that work? If a query and subscription go hand in hand, how many subscriptions can I put on one query?
So I think there's a bit of confusion around the vocabulary we've been using. When I say that you can submit a query, I should be more specific. I mean a subscription document. So
correct.
When we say you're submitting a request to the server, think of that as a plain text document, and that document can have multiple operation definitions within it, right?
Yeah.
I want to do the following three queries, and then we can execute all three queries at once, or we can execute a single query with three root fields.
Correct. Yeah. That's just GraphQL for you.
Right.
Yeah. So in the case of these domain events, mm-hmm. is the recommendation that you create as many events as possible to describe the event, or do you have one? Well, this is more in the implementation, I guess. But would you have one subscription, and underlying that subscription, based on the query variables or whatever, you make other decisions, right? So one versus many.
Yeah, excellent question. So the way we've built out subscriptions at Facebook is that we try to make the event as specific as possible.
Sure.
So the event might describe something like somebody just posted a comment to this story.
Yeah.
Or somebody just reacted with the following reaction to this live video. It's not, if we move up one level and say something, for example, we could create a subscription that said some node changed and here's the ID of the node, and we don't even tell you the type of the node, just go fetch it and try to execute some operation on it, right? And then we can kind of specify that a little bit with, is it create, delete, or update? We can do that. We just happen to not have done that at Facebook, and we think that we generally recommend that people model their events as as specifically as possible. Now, having said that, I understand that the GraphQL implementation of GraphQL subscriptions does operate at the level of being more generic. It does operate at the level of this thing changed, and here's the node type. But I think both solutions are valid. It's just we've had a lot of success doing it this way.
Yeah, and it's also preference at this point.
Yeah,
that's the great thing about the architecture. You can actually build it however you like. That's awesome.
Exactly. Yeah, the conceptual model doesn't really get into that level of detail of if the problem that you're trying to solve can contend with generic events and that works well, then yeah, go for it.
Yeah, definitely. All right, so let's get into what everybody's waiting to hear: implementation details.
This is actually okay. So I actually think this is pretty exciting. But I might be a little bit weird.
I actually love this type of stuff, but I know people feel like it's very dry. But I also have a lot of questions about implementation, so let's fire away.
Yeah. So we're going to try to map onto that conceptual model that we just talked about with some concrete details of how we actually implement this thing. And by the way, there are a variety of ways you can implement this. I really can't emphasize that enough. I find that generally we say something and something gets done a certain way, or somebody was the first mover and said, oh, this thing ought to be done this way. For example, GraphQL subscriptions ought to be done over WebSockets. Totally not true. You have a lot of choices.
You could do it over DDP if you wanted to.
You absolutely. But what I'm going to describe is an approximation of the system that we built at Facebook. And because it was used as the reference for what we see in open source subscriptions, it happens to describe the majority of GraphQL subscriptions out there in the wild today.
Okay.
So the first building block that we need for subscriptions is the network transport. And we need a different kind of network transport because one of the first conceptual requirements we needed was I need to keep track of this conversation that is open, right?
Yeah, we're stateful.
Exactly. So it's just like if you dialed me up on the phone. Right, we have an abstract notion of this open connection, and you can tell me stuff, and I can tell you stuff.
Yep.
So it's a stateful connection, and the transports that can support this kind of thing. Let's just throw out a couple examples. WebSockets, clearly, but also server-sent events, reactive sockets, HTTP long polling for when you don't have anything else.
Yep.
And then what we use for our mobile apps, which is MQTT. All of these transports fit the bill. So you can't really go wrong here, and we tend not to rely on any specific features at the transport level.
Yeah.
And typically, these stateful connections are going to terminate at some sort of gateway or reverse proxy, right? The reason why we do that is because if we're revving the services behind that, we don't necessarily want to break the connection that the client has to the gateway. The client should just think it's connected the whole time. And then magically we get new functionality, we get bug, we get higher throughput, etc. The second building block we're going to need is a place to store all that state, right? So what state are we talking about? There's a couple pieces that we can break it down into. We need to know which clients are mapped to which connection. So I need to have a notion of like, hey, I know I've got a connection with you, but I've also got thousands of other connections. How do I sort that and send something specifically to you? So I need a map of that. And then when you establish that connection, when you executed a GraphQL subscription over that connection, I need to track the actual query text you sent up. And you may have sent up several subscriptions, right? Using that same channel, you can execute 5, 10, 50 subscriptions. I'm going to need to keep track of all that. So I need to store what subscription you sent up. And I also need to know which events that subscription corresponds to. So that means the subscription server needs to be able to tease apart that query that you sent up and say, oh, it looks like you're interested in knowing whenever other users log in. Well, how do I detect that? So I need to know that, and then I need to basically register myself with the pub subsystem or the event system, whatever system I'm using to transport these domain-specific events. I need to say, I'm interested in this event, and that's another piece of state, right? Remembering who's interested in what event is another piece of state. And so these things can all be stored in any sort of persistence mechanism. You can use a distributed database, you can use a cache. It doesn't really, there's no restrictions there of like what kind of data that has to be. Just that these all come back to your scaling considerations.
Yep.
When you talk about, let's begin with a design that is clearly lacking. If we did everything in a single process, we can do away with a lot of this, right? We could just use an in-memory data store. We can just use the Node.js event emitter. But then if that process dies, we restart it, we would have forgotten who was subscribed to what, and then the clients would be in a bad state where even if we had this gateway.
Yeah, because our system is not fault tolerant in this case, right? And we also only have one process. So if we started another process and we switched containers, for example, is our state lost, right?
Exactly. Yeah. So I think a lot of these scaling questions you can kind of answer by doing the usual single point of failure exercise.
Exactly.
When you say like, look, we've got this cluster. It's got 5 nodes, 5 containers, whatever you want to call them.
Sure.
And one of them just dies for whatever reason, or the partition. What's going to happen? And that thought experiment can lead you to a solution where now, if you've chosen a data store, for example, that prioritizes availability over consistency.
Yeah.
Well, now you need to understand that the limitation of the system is that you might have a duplicate subscription entry on 2 different partitions of the network.
Yes.
And is that okay? What would that mean? What are the implications for your client? Does that mean that you're sending duplicate requests to the same channel? And then can the client do that, right? So unfortunately, I think we're going to get really, really far into the weeds if we try to follow that all the way through. Yeah. So I'll just kind of try to mention those scaling considerations at that level of detail, if that's
that's totally fine. It seems to me that the way we describe the implementation, that the subscription server and whatever we're using for our event bus, should be managed in its own cluster. It should be managed in its own way that it can scale itself, and it's kind of it is not a distraction to many other services that you're running, right? I do know though, like when we talk about subscriptions in the community right now, it's not at that level. It's not at that level of thinking. And I think we need to get there. Most subscription topics that we talk about, whether it's in the Apollo community or not, are talking about single server, single use case, message added, post removed. But that's not when you go to production, that implementation will fail because it does not scale across your containers. And you're not even using an event bus that is actually, that can actually that handle any load or anything like that. And exactly what we talked about. Process fails, the data is gone. And so I think a lot of these questions, as more people use subscriptions, they're going to probably have to figure out what we just talked about on their own, So maybe that's something better as a community that we can actually provide like the advanced use case up front. But anyway, let's continue.
And one pattern that I particularly like now that you mentioned, how you mentioned this idea of separating where the requests go, whether you have a cluster of services dedicated to supporting subscriptions. And I like that idea a lot. That is the way that we build our subscriptions.
That's how I designed my model as well. So
so it's great to be able to say, look, this set of services here, they support queries and mutations. I think it's very powerful to separate the notion of like this set of stuff over here, it's all stateless. The set of stuff over here, it's stateful. Here be dragons if you try to scale this thing. Exactly. Have we done all the due diligence to know what the scaling characteristics are? Now, that said, it is still reasonable to use the same container image. So for example, if you're building, if your GraphQL server is built into a Docker image, for example, it's okay to have that GraphQL server expose a WebSocket endpoint or an SSE endpoint, have it be able to serve queries, mutations, and subscriptions. But I think it's still a good idea to take that same image and split them across 2 clusters, where you mark one cluster and say this cluster is full of stateless GraphQL servers. All mutations and queries go here. And the other cluster goes, whenever you get a subscription request, it goes to this other cluster. That other cluster is totally capable of serving queries and mutations, except that it's dedicated to serving subscriptions because I know that this part of the service is stateful. And now I know I need to hook that up, for example, with a stateful persistence mechanism that is visible to all of these.
And you can also scale them independently, right? You can give them different concerns and you can grow them in any way you want. And the beauty of all this that I've learned over time is the client doesn't care, right? The UI that we're building does not care. So whatever, right? So we can have these battles on the back end, but at least our front end developers will still be productive, you know?
Yes. The front end will not know. It's the router will know, but it's okay.
Speaking of front ends, right? So we talked about PubSub. We talked about back end. I do want to get into PubSub a little bit more, but let's talk about the front end a little bit, just since we brought it up.
I want to, before we jump there, I just wanted to finish. You mentioned 2 of the 3 building blocks that we needed for the implementation. I just want to mention so that we close that conversation.
Yeah, definitely. Go.
So the third one should come as no surprise. We need some sort of an event system. We've been talking about this notion of an event, domain-specific event. Well, now the rubber meets the road. You actually need to be able to detect this event, and you need to be able to publish this event to all participants that have expressed interest in that event, right?
Yeah.
And this is not any more complicated than it needs to be. You can use any sort of pub subsystem off the shelf. So the Node.js event emitter, for example, is perfect for a simple in-process pub subsystem. Just know that when that process goes down, any sort of delegates you registered as event callbacks for the event emitter, they're not going to get restored for you automatically, right? So if you want to outgrow a single process, then you start to think about distributed pub subsystems like Kafka, Redis, or MQTT, or RabbitMQ.
Yeah.
MQTT also if you want to use it, but these. So this third building block, So the key thing to remember is this: you only need to really use this thing when you have scaling needs, right? This is all to do with the state that we've tried to talk about in step 2. This is part of that state of remembering who's subscribed to what. And we have found it generally beneficial to not dump all that into a single store. We could, but it's not. We find that components tend not to be purpose-built for this kind of thing. So for instance, you could just use Redis everywhere, right? Like, why not dump all of the connection mapping data into Redis? Why not dump all of the queries that a user has sent up into Redis? Why not and then use the Redis queues as your pub system? Why not is
why not?
That's a really good question. Why not is just because, like, we find that these systems, they're good at you want to be able to tune these individual aspects of these systems. Yeah. So for instance, the pub subsystem that we use at Facebook is a proprietary in-house pub subsystem. Why did we not use one of these off-the-shelf systems? Because take, for example, streaming comments. Yep. It may be the case that if you join a really popular video from a celebrity or something, the rate at which people post these comments is extremely high.
Yep.
And if your rate of comment ingestion is something like 100 comments per second, we actually need to step in, because it doesn't make sense to send 100 comments to every client who subscribed. First, because it's an n-squared fan-out problem. Second is that if you did it, it would be a really bad user experience. And as a result, all the client would do is just say, all right, you're giving me way too many comments. I'm not going to display all of these. So we're going to be wasting a lot of resources for no good reason. And for that reason, we find that the pub subsystem actually needs to be able to support all sorts of filtering and throttling semantics, right? Yeah. And you can build these around Redis, but wouldn't it be so much better if you just chose a solution that was purpose-built as a pub subsystem rather than a generic data store, right? So that's the most compelling argument I can give for why you would want to separate these things and not just create
that makes total sense.
It's all stored for all your state.
Yeah, that makes complete sense. That's interesting. So you guys are using custom PubSub, and was that built prior to GraphQL subscriptions and was used for other things and brought in? Yeah.
So this is a really cool service, and we haven't talked about it much. So I don't think I can say too much about it, but It is a general purpose PubSub system, and we have a team of awesome folks that we work with to build this system, and it's content agnostic, so it just treats GraphQL subscriptions as one use case, and it powers a lot of other really cool use cases.
Okay.
And one of which is like presence indicators. Like if you go into Messenger and you look at something like who's online, that kind of feature, the notion of presence, is another one of these features that the supports.
I see. So in the case of these PubSub systems, how do you guys ensure that the messages are comply to some type of shape, right? Does Facebook have a standard of the messages that they are publishing to these event systems? Does every event look the same?
Yeah. So without getting into too much depth with these pub subsystems, so these pub subsystems are a special variant of pub sub called a topic-based message system, right? In other words, you and I pre-negotiate this idea of a channel, and this is just a string, right?
So this is like Google Pub Sub, like for sure.
Exactly. So this is a very popular variant of pub subsystems. So we can say, hey, we've pre-negotiated that if we both join a chat room, then we will use a scheme that says we will say chat room, and then we'll append the ID with a colon as a delimiter. And then we will use that as the topic. So if you and I care about events on the same chat room, we will, by that convention, end up subscribing to the same topic. And that's how we get events flowing across both of our applications. There are other variants that I think we considered briefly, but we decided against using. So one of these variants is the type-based event system. So type-based event system, you could say something like, at the top level, I have a generic event, and if you subscribe to a generic event, you get every generic event. Right? And then at a level below that, you can say I have a notion of a node event. And at a node event, what are node events? Well, these are create, read, update, deletes, right? So you can subscribe to those, and then you can say you can get more and more specific. But you can imagine that these events have their own type hierarchy, and at any time you can subscribe to something based on its type. And now you know that it's got some sort of inheritance hierarchy, and you can always go up the stack. And the data that comes with that kind of system tends to be much more structured. But because all the different types of services and use cases around the pub subsystem, we thought that it was best to keep this pub subsystem as a content agnostic microservice.
Makes sense. Awesome, man. You know what I've been thinking, like all these implementations, concepts for GraphQL subscriptions, it really makes real-time development more approachable, right? Like we're talking about these concepts that maybe people have never heard of, but now I think may have a little bit more confidence to like dive into, because I don't know about you, but you're making it sound super easy, right? Like I think anybody could achieve a real-time system using GraphQL subscriptions.
I mean, that's definitely our goal, is that I think, GraphQL, our vision for GraphQL is that it's a technology that empowers people to build stuff. And I think we've made great strides toward that goal with what we'll call vanilla GraphQL, with GraphQL, the specification, the reference implementation, queries and mutations. People have really taken a liking to it. The model makes sense. And with subscriptions, the challenge has been exactly what we've been going through. Like we can describe subscriptions at a conceptual level in the specification, but when we get down to the implementation details, it's more difficult for us to go and provide a blueprint for how all this fits together. And that's where I think our community partners, Apollo and GraphQL, have done such a tremendous job of providing documentation, providing technical deep dives, providing backend as a service. So this is exactly. I mean, if people find real-time applications more intuitive, easier to build, then I would be blown away. That's our goal.
Yeah, definitely. And that's actually a good segue to our next topic, which is the RFC process. So you mentioned that GraphQL and Apollo support community partners that support subscriptions, but the fun fact for the audience is they supported subscriptions before subscriptions were a thing in GraphQL, right?
Yes.
And so I would like to understand how this process works. There's this great feature idea, and this is kind of like if you've ever read the Valve employee handbook, it says if you ever have a good idea, get another person and go build it. And that's how it happened. Like people like Uri Goldstein and the guys at Apollo and girls got together. And they're like, yeah, let's do it. Johannes definitely was like, we got to do subscriptions. And subscriptions weren't even in the spec, right? They were like ideas that were in one talk, I think, at one point. But explain the whole thing. So, let's get into it.
Yeah. Well, I mean, you've had those folks on the show, so I wish they were here to give their side of the story. But my understanding is that, we talked about subscriptions, and because GraphQL made so much sense, and because it had so much uptake in the community, this idea of, it's just queries and mutations, how do you deal with real time, came up very quickly. And for a little while, it just kind of stewed in the open source community. Like, okay, I see how this is an improvement over my current RPC style APIs or my REST APIs, but I have this other tack on system that delivers real-time updates. how do I fold that into GraphQL? So this was the idea of using GraphQL for real time has always been around, just as this is the same journey that we traced through when we built it internally. And I think it all began when Dan Schaefer and Lenny Kenzel gave a talk. I think this was in early 2015, and they talked about subscriptions just pretty casually, right? It's like, hey, there's this thing called subscriptions. We've been building it internally. We've been rolling it out. Here's what we learned. And the idea was, as we went through here, it's exactly what we just described.
Yeah.
And people looked at it and said, yeah, I get it. That makes sense. We can just do that. And so I think Apollo was just, at the time, they had also began to bet heavily on GraphQL. And so they thought, hey, why not? This is a great opportunity to build something that the community clearly needs and that we are in a great position to deliver. And it seems that, like, you know, what does Facebook want to do with this? It's not absolutely clear yet. And then the conversation, so once they started building this, we realized, like, hey, the implementation you have is great. It certainly works. It's a little bit different from what we have internally. And we think we all agree, we agreed immediately on all sides that this is something that's really useful to include in the specification. The question was a matter of tactics, you know, how do we include it? How do we roll it out? What parts are built? Who owns what? So we just started collaborating with them. And huge props to Sashko and Uri for being such great partners on this work. Lee Byron as well. I mean, you know, we all kind of worked together and made sure that this thing made sense. And so, you know, they definitely had a couple of versions of subscriptions that were working without.
I've used all of them.
What's that?
I've used all of them. So
yeah,
every iteration, every breaking change. You know the history then.
I've
been there.
So basically, we have this. We basically said, okay, how do we get this into the specification?
Sure.
And that really kind of that conversation kind of coalesced earlier this year, and we thought that this was the perfect opportunity to beta test the RFC process. So we kind of used the RFC process as a template in order to get subscriptions into the specification. That's
great. So let's go into what the RFC process looks like. And like, let's say like I want to build a new feature in the spec. You know, what do I do? Yeah. So the RFC process is meant to be a lightweight process by which we evolve the GraphQL specification. It was loosely based on the TC39 process. And the idea is that we want to be able to have a conversation about any proposed changes. We want to have a phase in which we evaluate the change, in which we have a concrete proposal, and then the final phase where we finally add it to the specification and then update the reference implementation to enable that feature. The reason this kind of process is necessary is because, as I'm sure you're aware, there are lots of implementations of the GraphQL specification. GraphQL servers in just about every imaginable language. And we also constantly get these questions of, oh, well, as a community member, I really love GraphQL. How do I contribute? How do I help GraphQL evolve? And so it's important to keep in mind that GraphQL is a critical piece of infrastructure for Facebook. We rely on GraphQL more than anybody else. And so we can't simply allow GraphQL to evolve in arbitrary directions. We have to actually try to keep a really close eye on it, both for our benefit and because of the nature of where it sits in the stack. Yeah. As an API query layer, GraphQL is not the kind of technology that you want to be fashionable and hip and reacting to trends like, oh, let's make everything functional and reactive, right? Mm-hmm. Like, you don't want it to do that. You want it to gestate, and you want it to age well. You want the API layer to form a rock solid foundation on which because your back end is going to implement it and your front end is going to depend on it, right? So you definitely don't want things that are churning the spec, because if you churn the spec, you churn the very definition of GraphQL, which in turn churns all the server implementations, and then that has a downstream latent effect on the people who use it, and over time it will create this perception that this thing is not reliable, that there's no real good story around it. So the RFC process was designed to address all of these things. Totally.
And we thought that the subscriptions definition was the perfect example because it is something that had already been built and rolled out to scale. So we knew it was useful. We had lots of positive feedback from people using it internally at Facebook that this was the right thing to do. And we had a lot of community interest in it, especially being spearheaded by Apollo. So we felt that certainly that the time was right, and then that we could use this as an opportunity to walk through the RFC process. And I can go into a little bit of detail about how that went as well, if that sounds interesting.
Yeah, let's go through it.
Yeah, so all this history is on GitHub, but just to give a quick summary, this began with a very simple plain text proposal. So I drafted up this RFC proposal, and this is something that anybody can do, right? You can go to our GitHub repo right now, and you can create an RFC. And the important thing to note is that you want to explain what you're trying to do and why to as many people as possible. Because ultimately, the RFC process is about collaborating. And you want to make sure that people can understand the issue well enough to debate it and give feedback. So we use that initial RFC document to try to generate as much discussion as possible. And it generated a huge amount of feedback. So the next challenge was to kind of organize that feedback and resolve the concerns. Now, this is where I think the GitHub tools are not very well structured. It's clearly not designed as a forum. So, we had to do a little bit of creative teasing apart of that master issue. But eventually we were able to break that out, take conversations, have more focused conversations on the feedback, and then merge it back in and say, okay, what about the original RFC had to change? And so once that thing was in a good place, the next step was to say, okay, what is the actual spec text that needs to change? And you can find that as a PR against the spec language, the spec document itself. And that's the thing that describes what a GraphQL response stream is. It describes the abstract algorithms that we use to execute GraphQL subscriptions.
Yeah.
But that's not the end. That just updates the spec. And as you know, we need to update the reference implementation. Yeah. So that was the next step, which we worked very closely with Apollo on to actually PR the changes to GraphQL JS, which included the implementations of the algorithms that we had described in the specification. And then after that, we actually need to go and update all of the ecosystem of libraries. So for example, the Apollo subscription transport NPM package, we needed to go update that a little bit. We needed to update some of the documentation that we had in a lot of places. And then you alluded to this thing earlier, which is like the community right now is in this place where they're dealing with relatively simple use cases of subscriptions.
Yeah.
And, we get this question a lot of, okay, this seems great, but there are some clear scaling limitations to this. How do I build this thing that can withstand single points of failure? How do I build this thing so that it can support, millions of concurrent connections and millions of publishes a minute, for example? And so we definitely want to provide that documentation, references, and best practices in the future.
Yeah, great. All right, so went through the RFC process a little. We have last thing on our agenda is this thing called live queries that we talked about earlier. And I think we should close the show with kind of looking at live queries and what it is and how subscriptions relate to that. And then we'll get into picks after that.
Yeah. So live queries. This has been a very interesting debate from the very beginning. Subscriptions. I had mentioned that the key concept in a subscription is this notion of a domain-specific event. Not only do we need to detect that event, we need to publish the event, and then we need to react to the event, right? And that's where live queries and subscriptions start to part ways conceptually. A live query doesn't necessarily need a domain-specific event. The best way to think about live queries is you take a normal GraphQL query, and you just pull that GraphQL query, and you pull it infinitely fast so that you can detect every possible state change. Now, obviously, if you were to actually try to pull a GraphQL query infinitely fast, you would have a lot of responses that are totally wasteful.
Yep.
And so not very efficient. So we conceptually think about GraphQL live queries as simulated infinitely fast polling, just extremely optimized. such that it's only pushing changes when it detects a difference. So the next question is, okay, well, they seem to both be able to fit the bill of I want to detect when something changes. And that's true. But let's take our chat room example from earlier that we modeled with a subscription and try to model it with a live query. In the subscription case, it was pretty clear. You said for chat room ID 123, tell me whenever somebody joins the room.
Yep.
And then from that, you can say, well, what was the name of the person who joined the room? When did they join the room? Because you know the event, the thing that caused the change, the reason why you're receiving a payload is because somebody joined the room. That was part of the query that you executed. But when you execute a live query, it's not associated with the event. So something fundamental changes about the interaction with a live query. How would you do this with a live query? You would, instead of asking for whenever a new user joins the room, you can't use the word whenever anymore.
No, yeah. You have to observe.
Right. You just have to observe. So you observe. Let me observe the list of users in chat room ID 123.
Yep.
And the notion of observing that list of users, let's take a naive first stab at this. Let's say it just returns a flat list.
Sure.
And at T0, it returns a list with 5 users in it. And at T1, it returns a list with 6 users in it. So what intuitively seems to have happened is that a user joined the room, right?
Sure. Naively, yes.
But do you know for sure?
You don't.
Right? Like, no. So already you can see that this kind of starts to shape the interaction from the client's perspective. Let's forget about how we implement.
You need more technology on the client.
Right. So as the client, you now no longer have this notion of a domain-specific event, and it turns out that the domain-specific event is pretty useful even to the client. But that's just that. In general, we do think that live queries and subscriptions are isomorphic. That you can take that example of somebody joining the chat room, you can keep a list of who's currently in the chat room, you can get the new list, you can diff it, and you can say, okay, now I know that the delta between this list is that somebody joined. But I could have gotten into that state by having somebody leave and 2 people join.
Sure.
Right? So you can have all these different variations, and the client now has to do a little bit more work to suss out what event actually caused this thing. And then that said, like, there are some things that live queries are better for, and there are some things that subscriptions are better for. So the conclusion we came to is that they're semantically different. And when we detect a semantic difference, it doesn't matter whether we can use technology to pave over the differences at an API level or at a transport level. It's not going to be super useful because some use cases are just going to naturally gravitate towards some solution as opposed to the other one, right?
Sure.
And so we had this opportunity to say, like, okay, well, are live queries going to obsolete subscriptions? And after a bit of soul searching, we decided, no, they're not. They're 2 different things, and we're going to want to make them both as awesome as possible.
So this is where I get tripped up with live queries a lot, and that's because usually you have to have a reactive backend, and that has some notion that you're either watching your database at some level, right? You're watching some log, and now your subscription architecture is tied to your DB, right? And so that kind of gets kind of whack, And you could build something a little bit more elegant here. But I'm just like saying, like, let's say it's connected to your DB, and as you observe these list changes, right? You're going to get responses to the client no matter what. So now the client is forced to have a local cache that it then diffs, maybe, right? It's just diffing data it gets versus what it has, and then re-rendering. Like, that's a cool system, but let's say your database is the bottleneck of your whole system. And so every live query you have, you're screwed. Like, you're essentially screwed, and you can't scale. I don't think you can scale that, right? And especially the thing is, what if that list is 1,000 people in the chat room across a bunch of users subscribing to the same data? Like, this is where live queries get super tricky when it gets into scaling. But conceptually, like, I totally get it. It's just like these are the tough problems that we need to face at scale with live queries.
Yeah, absolutely. You're touching on some really good points. You're talking about a single reactive database being the scaling bottleneck, but
potentially
the case that so imagine that when you execute a GraphQL request, part of the data in that request is fulfilled by hitting your reactive database. That's fine. You can observe that pretty easily. But part of it goes and talks to a flat file sitting on a server somewhere.
Yeah, definitely.
What are you going to do? Are you going to have Watchman on that file to generate? So now you need to join two different kinds of reactive streams. And let's say yet a third part of that request comes from a REST API call out to, weather.com.
Yeah.
And they don't support any sort of reactive API. So you need to just execute, you need to set up a long poll with that thing.
Sure.
Just to know when that thing changes. And then you need to manage the state of that. You need to know, okay, well, when does the client no longer care about this live query so that I can stop polling weather.com, right? So you can see that like it's a huge lift to add this thing to an existing polyglot backend system.
Sure.
And there are some. So we've been building and experimenting with live queries for a while now.
Okay.
We've encountered these kinds of problems in all shapes and sizes.
Sure.
So I think this is a great opportunity to plug that we're going to be giving a talk on live queries at the GraphQL Summit.
Are you giving the talk on that?
I am listed as the speaker, but we are still trying to sort that out as to who's going to talk. But we definitely want to share what we've done so far and what
that's exciting.
And yeah, so I'm really looking forward to that.
Interesting.
Suffice to say, there's a lot of really hard problems. There's a lot of really interesting and novel solutions.
Interesting. Yeah. So now just getting in the weeds a little bit, are there any hybrid solutions to this problem where you're observing some document that is being updated via an event system, right? Like a mix of, it's a mix essentially, right? Like how the observe happens is based on an event system, but you're still using live queries, right? Is there some type of hybrid there that we could achieve?
Yes. I think that without spoiling anything, that is the kind of system that we have to build in a couple of cases. Yes.
Okay. Yeah. All right.
Absolutely. You're onto something.
Yeah, for sure. I've been thinking about this problem a lot, so it's great to have someone else who's also thinking about that too.
Yeah, it's a huge problem. It's very interesting, and there's a lot of opportunity there for sure.
Awesome. Okay, so I think that's all the time we have for today. I wish we could keep speaking, and maybe I should just come join you guys and make some moves over there. But because this is a really exciting conversation for sure. We just want to thank you for being on the show. We do picks at the end. Picks are kind of just shout outs to either maybe like, your favorite clothing company or like the food you ate or some restaurant you want to recommend, things like that. It doesn't have to be technical. I'll go first. My pick is actually GraphQL Summit. They'll be releasing the full speaker list soon. And Rob is on the speaker list currently. Whether he speaks or not, who knows, but he's on the list right now. And Johannes is on the list for the speakers as well. So half the GraphQL radio team is on there, and maybe another person from this team will be on that list too. Who knows? And so that's my pick, GraphQL Summit, October 25th and 26th. Next show, we'll put it on our website, but we'll get you guys a coupon code to buy tickets to that. So GraphQL Summit.
Okay, my turn?
Yep.
All right. Well, you took some of the wind out of my sails. I was going to plug GraphQL Summit. It's a great event. Everything Abby said is true. But also shout out to you for organizing this thing. I think it's a pillar in the GraphQL community, and I understand that it's a lot of work to keep up with this kind of thing. So I really appreciate it. A lot of people on the GraphQL team listen to this podcast, and they all love it. So keep up the great work.
Thank you.
Of course, shout outs to our partners in the open source community. Apollo, GraphQL, you guys are amazing. And then just shout outs to everybody who participates in the open source community. If it's just filing issues, fixing documentation, submitting PRs, implementing a server in your favorite language, you're what makes this community awesome. So please keep all that work up. And I look forward to seeing all of you at the GraphQL Summit.
Awesome. All right, guys, thanks for joining us today. Last minute housekeeping. Starting next show, we're looking for company sponsors for the show. We're getting to that size, which is great for the show, that we're having a lot of viewers now. We would love to get some company sponsors to maybe help us with some merch or whatever. So if anybody out there wants to contribute to the show, just email hello@GraphQL. We'll be setting up a Patreon soon and all that jazz that typical podcasts do. But, whatever, right? That's just what people do. So thanks for joining in, and we'll see you next time.